Vitaly. I'm co-founder and technical director of the Huntflow company, and it is the base for recruiters. If you, for example, place your resume, your CV at HeadHunters, the recruiters save it in the database, they start communicating, they show it to the employer, and our task was to inbuilt email client into the server to be able to write the letters to the candidates and to receive answers, so that it could be done not only in the email client but on the service, so that if the recruiter is gone or on vacations, the other recruiters might pick it up to see what was going on. And of course we started to analyze the standards. In reality, of course, not anyone is doing that, but the email turned up long ago. There are many RFC, and the first email message looked like that. It resembles HTTP. There are headers, and there's body. And first, the messages supported the ASCII, and it was first to whom, from whom, the subject and the body, but it was a long time ago, in the 80s. And of course time is running, and people would like not to write in codes, but in Russian, Chinese, English. They are willing to send the pictures, files, and that's why a special extension was the so-called mime. It extended the protocol of the email, and it added the opportunities not to send text only, but files, and it added a few types of content. There are some 10, but I will discuss 3 of those. First is mime alternative. It is the type of the content that we have a message and a few representation of how it should look. The easiest example, when you write an email in the client and if you make it bold or red, it is HTML format, and your client understands what you're doing, and the letter is sent in 2 formats. One is just a text, what you have written. Another, it is HTML, and the standard requires, when such a letter is written, to show the least supported and then the most priority, the highest priority. And if your email client opens it in HTML, then if all the patterns and shifts and the others could be shown as well. Another example, the alternative representation. If you receive an invitation to the calendar, it is also an alternative format, and you could have seen it. There is a beautiful badge, there is an event in the calendar, and you can also choose whether you come or not, accept or not accept, and this is also done on my type alternative, and there are additional my types with the content types. The email client understands the calendar, and it sends you an icon which is prioritized per you. Another format is multi-part mixed. It is a mixed content when you want to write a text and attach a file. Text is one content and the file is another content. They are not mixed, and that's what it is. And the last thing I would like to talk related. The difference between alternative is as follows. When you write a message, you not only want to make it bold, but make it underscored. You want to have a picture in the text. In this case, related is used. You have a major content, it is HTML message, and added is the content with the picture, and accordingly text source has got an attribute, it is image, and it understands what picture should be drawn and written. And altogether it looks like that. It is the message that has two attachments. It has got a text HTML and two images in the HTML. This is a standard email, and here is a test from Mark Christen. It is the developer of IMAP, and he developed a letter, a message with the 30 levels of attachment, and it is used in the libraries for libraries to work with the emails, should know to process it accordingly. And there is a link to this particular test. So we are through with the theory, and now let's talk about Python. Everything is fine with email in Python. There is a standard email library, and it can do many things. For example, you want to make a message with text or HTML. You select a multi-part alternative, and you make a text, and then you attach the two types of my text, plain text and HTML. And after you choose the method txt, and it automatically converts the letter into the decoded type. Nothing else to do. That's when we make a letter. If we read a matter, everything is available in Python. There's a message from string function. You feed it to the text, and if you have multi-part, there's a method, and it tells you to bypass all the tree of the message and to select the required information. And now a few words on the library of sending and receiving letters. There's a standard library. You just import it, and you start TLS, you log in, and you send the mail message string, and everything is working just fine. No problems could have been identified. The only thing, it is the size of the message, because different emails environment could have different extensions. And one of the clients, one of the customers, have been telling me that there were any problems if it's too heavy. And it turned out that the optimum size of the email that pass almost all these servers is in the area of 15 megabytes. If it is more, then the servers would reject it. And when the main format, multi-proposals image message extension, and the files that are sent through mail are not in binary but base 64, and it takes up more space than the previous one. So talking about receiving the email, the first protocol, the very first, is POP. The latest version is POP 3. There is POP-lib in Python, and it works pretty simple, but there are a few nuances. POP works as a mailbox, and there is a pack of letters. You cannot say, give me 3 letters. You can either take all, you can read them, and either delete it or put it back. There's no possibility to somehow see which letters you need or which you do not need, like the letters that you have not seen yet. So that's why there are many constraints. You cannot store a lot of messages. If you have 1,000 messages, then the performance will be no good. But I would like to talk about this pop, because there's one function. You have a list of the messages and you start reading. Then, due to our specifics, so the specifics of our company, we work as an email client to support recruiters. We should not interfere with the users using their email. The user should not know anything. They might know that we are handling the email, but the user, we should do it in such a way that they wouldn't read it. The major thing is the status of the written letter. So if retrieve is left, then the person receives it as a written email. And when we tested the protocol and we had a challenge, as a result, the picture was that all the messages were marked as written and they wouldn't be looking into anything, and we managed to find the code that does not mark the letter as written, and it is reading the letter piece by hour. But I would like to mention that pop format is obsolete. It could get the content of the whole of the box, and it has got only one go. And another challenge, another problem is that it does not offer you to store the sent messages. If a message is sent, pop is and SMTP, and it is just stored on the hard drive, and nobody knows about the service. So if somebody sends a letter from our service and does not see, he starts asking where the letter is, whether it was sent, whether it reached the recipient, and so it's not clear. Then it's not recommended to use pop, and I will give you more details. But there was another protocol that took over from pop. It is IMAP. It has got the IMAP Leap, and it is supposed to get rid of the issues that were in pop 3. First, it enables to say that I just read only from the inbox, and they does not mark the messages as read. And here are the reds, the functions. It is read only and peep, and it is possible to build folders. And the first call is inbox, and of course it executes different commands. You can say I don't want to receive all the letters, but say the letters since after synchronizations, and you can read not the whole of the inbox, but just those that were written. But we still face a problem. It has come from Mail.ru. It does not support that kind of format, and we have been discussing it with the developers, and they said that they did it on purpose so that the offenders will not, the malware wouldn't find the letters with the codes. And consequently, another important thing is that IMAP makes it possible to receive the information by pieces, not all the headers or not all the texts. You can make a request, and you will just get the so only piece of it, like message ID, and we synchronize the mail, we receive the letter, message ID, and we change the status, like we read it and we have evaluated the candidate, and in doing so we optimize the load and the overheads. And there's another keyword peak in the request, and it gives the command that this particular message should not be flagged as written. These are two flags, so that the message is not marked as written without the customer realizing that those were not. And there is another command, fetch. It is to return the letter in the format RFC, and a class of message is assigned, and you're handling it later. IMAP had got a lot of problems similar to POP3. Overcoming the issues of POP3, it is possible to save the sent letters and different email servers. Make it possible to understand the tree, and we made a hack of if the files are sent, we assign a name, and that's what we did. And if you find IMAP in the directory, then we can select append, and we add plus in, and it marks the letter as written, seen. Next, how to connect the email. We strive to minimize the necessity of using the IT specialists that should come to enter the addresses of the email servers. That's why we show the simplest form, email and password. And those are entered, and we use the domain part, and we try to get to the server and to find whether it's available or not. If it's available, we log in, and if we manage to do that, we add the email, and the email is automatically added. If we do not manage to do that, then that's what it is. This particular format, it is to train the specialists who are not developers or programmers, but sometimes it's not possible to fill it in. And I have covered the protocols, but there are two more things I would like to mention. The first thing is, of course, Gmail. It supports the standard protocols, and it has got an API. Why? Because it's no good for SMTP, and it has got auth tool, and it makes it possible to work with post and with the calendars and transactions of the users. When a message from the services is written, we can show and tell the email of the person from his company. It is convenient, but there are problems. The limits are very light, and I have mentioned that we store message ID so as not to receive the letter again. This is done to deal with Google. We had a situation in the first test that we could not send the message, and as a result, at every cycle of synchronization, it was sent afresh. And after a few attempts, Google bans that, and next time it will be possible to do that only after 24 hours. Of course, the customers are pissed off, and banning is very fast, but what's good is that they ban just by API and by users, and not completely, not 100%, and only one user could be banned.
It's also quite easy to work in IP. There are several methods of sending messages. For instance, using a Google format through shaping a dict and then JSON. And the simplest way is through using our library of email, making a strict, and then send it out. Just to demonstrate the format of sending. Everything seems quite good. And it looks like there is a 15 megabyte restriction of Gmail for sending messages. And another one is of Microsoft services. It's called Exchange. It's a mail server of Microsoft. It has IP for Exchange services, which makes it possible to, through using a particular URL, send letters. It handles not only mail but also calendars and multiple users. The only thing is that it has standard Windows identification, which requires a description of user domains, and it also has a basic configuration which uses cloud-based solutions. And basically, speaking about URL 365, it also has an IP, but we didn't do it because Microsoft distinguishes between cloud-based things and the servers based at companies. That's why, to provide for a single interface, we only use URS, and it is used by all of the corporate networks, and we also have to support it because corporate users have their exchanges supported by IMAPs, but for 95% of the companies it is closed. Nobody wants to support this standard. That's why everybody closes it down. That's why the only normal way for meeting is through URS. But also, speaking about URS, there is also a library to handle Exchange Web Services. Last commit was in 2015, but it only supports work based on calendars and not email. But it has a good fork, and we found a good fork. And in fact, the protocol there is quite simple. It's a normal SMA. So basically, every functionality supported by URS can be done by us, and then everything will work. And that's why we found a more or less good fork. Then we adjusted it and adapted it to our uses. In addition, our statistics showed that a majority of our users use Google. It's around 60%, because most of our clients are IT companies, and the most important thing is that there isn't a single customer using POP protocols, so we can say that it doesn't exist anymore. There is IMAP, there is Google, and Exchange. And corporate users use either Exchange or Google, and simpler companies such as Yandex, which has built-in mail, have IMAP, and And another important thing is that when synchronizing user messages, it's important to understand what it is all about. There are headers which try to link the messages into chains. So when you reply to a message, then it is built in. If the header is long, then there is a special type of header where all the messages are enumerated. It works pretty well along this line, and practically always. There are some subtleties that we have encountered with. For instance, there's a mobile client of MyCom service. So if we are to reply to a letter using it, and if we first keep it in drafts, then that email client would cut off the headers, and it's impossible to find a link with the chain. But after we spoke to the guys dealing with it, they promised to do something about it. In addition, email clients try to put together the same letters into a chain based on the subject of the letter. We don't do it because the service aims at automation. That's why quite often some templates are used. So if we were to put them together based on the same subject matter, we would have a mess on our hands. And now speaking about the synchronization, we actually do synchronization every 2 or 3 minutes. Then we prepare a list of messages depending on the time of the latest synchronization. Then we check if it was already synchronized. If there was no synchronization, then we do complete fetch. And then we look through the headers, we search the emails in DB, and then we add it to the chain and put it to the applicant history, so that the user can see the whole chain of correspondence in the card. So what is it that we haven't done yet? I have already mentioned it, and I do need to elaborate it because this is a must-do. First of all, it deals with sending and receiving messages in HTML. Why so? Because currently it is done in the text. So if it is sent and received in HTML, then we read it in HTML and then use an envelope. But it was done because in 2017 the content and the preparation was okay. But in email clients it is just the same as it was in the 1990s. Because the letters are scrawled using tables. So everything is too sophisticated, to say nothing of the fact that just reading out the messages from our users is not so easy, to say nothing of a beautiful presentation. And obviously there are some concerns about safety. Above all, since if you download HTML, you need to show it. Certainly for this purpose, the Bleach library could be helpful, but the disadvantage is that if it bleaches things, they may turn out to be quite different from what one would expect them to be. And there is also such a thing as anti-tracking. That is to say, to learn if the user has read your letter, it may put a picture. So once you load your computer, you will see that picture to learn that your letter was opened by the other user. So this is the way it works. That's why it also needs to be handled and processed. And just like all the other email clients do, the pictures are then converted and downloaded so that the user could open the picture not from the server that you had used, but from its own place. And certainly this needs to be taken into account, but we are about to do something about it. And there is another thing. During correspondence, people just write to each other and they quote things. And quotations are really another headache because every client applies its own quoting processes. Google has even got a patent for quotations, because if quotations are quite different from the original, a punishment may follow. I think this is the end of my presentation. It's everything I wanted to tell about. Yes, please. Who is going to give the microphones to the audience? Can't hear the question being asked, so it's impossible to translate anything. Are you referring to reverse synchronization? Yes, we have thought about it. Gmail also is capable of using pushes, but given the increase in the number of clients, we thought that we should better not go for pushes. We have Tornado. We could do something about it. As a matter of fact, it is really possible, but it's also something that we haven't done yet. And given the current number of clients and load, it is enough for us to have just 3 or 4 workers to do it. But when the number grows, we'll certainly have to look for pushes. And we should also understand that ERS and Open do not support any pushes. That's why we'll have to synchronize them in the classical way. But there is no pop-up, so it makes no difference. Once we remove it completely, it will make a difference. And you mentioned the fact that there is a Python library where everything is okay. I said nearly okay. What are the problems that you have faced there? The key problem is probably not related directly to the library. It's rather that of email clients, because every developer interprets it in different ways. So we had a problem with the coding, and that's why we had to reread them in Gmail, because the coding was different for the content, and that's why we had to decode the headers first and then the content. And that's why we had to use Chardec type libraries to correctly identify the content coding. I think that was the key problem that we faced. The rest was more or less okay. I haven't heard my favorite question about safety. That is to say, how do you keep your users' passwords? Could you answer the question that you have asked? Well, I was just waiting a response from the audience. As I have said, with Gmail, everything is okay. But with the other protocols, we do have to keep them, and naturally keeping them deciphered, it would not be just unilateral but multilateral coding. But there are clients who say that they would not give away their password. That's why we have to set up separate boxes for them, email boxes. So there are corporate email boxes and those used only for communication. It looks like there are questions straight away now. Hello. My question is as follows. Using your server, you do everything with Python, but what do you do to avoid or to prevent letters from getting into spam? The thing is that we get connected to the user email box and send a letter on his or her behalf. So the problem of spam is that of the administrators of the email servers that we get connected to, but we haven't had any problem with it. This is one of the reasons for the fact that we were using just other emails instead of using our own in-house server. Just not to burden our memory with vacancies. That's why the candidates would add spam. In that case, our server would very soon include it in spam lists. But that's why, for these reasons, we decided that we would have a separate email client using users' email box, and therefore it will be the user who is responsible for these things. Thank you. Is that it? Then after party will follow.